Hello there, Bentley, too damn many projects. Another project. Oh, they never end. They keep going. This is a beginning series we're doing on my YouTube channel, and we're going to talk about electrical systems for things like motorhomes and older boats. A lot of the newer motorhomes and a lot of the newer boats don't have these problems, but if you've got like a 2000s, 2010 motorhome or a boat that was built before 2005. A lot of us have boats built in the 80s and the 90s. You have this problem. But we're going to focus on motorhomes right at the moment because I'm going to tell you why your motorhome has problems. Why your batteries go dead when you're off the grid. You go out camping somewhere with no power, get up the next morning, the furnace isn't running, you're freezing to death, the freezer's thawing out, can't do anything, now the motor won't start. You know, everything's a screw up from the word go. You got to get some help. And the reason you do is because the system's built wrong, completely. And I'm going to show you why it's built wrong and how we fix that. I'm experimenting on an older motorhome right now with things we've completely revamped. And I'm going to show you some things that you haven't seen before or heard about but didn't pay attention to because they didn't seem that important, but they are. This is a very quickie electrical diagram, okay? When you have a motorhome, just remember what the manufacturer did. He took a truck, okay? He bought a truck with no body on it, and then they put a motorhome on it. But let's start with, what does the truck have? What are they starting with? When you drive off in a truck, you have a battery, okay? There it is. This is a symbol for a battery, all right? That's your positive side, that's your negative side. Yes, it grounds into the frame. On a boat, you don't ground the frame because there's no frame. All right, so you have to have a ground wire going to whatever accessory you've got. But this is the basic system that comes on a truck. You have a battery with a cable that goes to the starter, another cable that goes to the alternator, another cable that goes to your accessories. I got X, Y, Z there. This accessories I'm talking about now are the lights, the radio, the horn, the coil, the engine, the fuel injection system, the computer, everything that has to do with the operation of the truck. Right there. This is the starting system. This is the charging system. I have a black wire here going back to battery to symbolize the ground, so you have an idea. It's all a circuit. Circuit means circle. Okay. Without a circle, you got nothing. Okay. But here's what we're doing. All right. You got this truck. You're driving around, and the alternator. This is my first pain in the ass. These alternators have an internal regulator. The problem with an internal regulator is you don't get 100% of your charging power because the internal regulator shuts off prematurely. That's one problem. Number two, if you look at your truck or your car, and let's look at it this way. See if you can figure out in the specifications for your vehicle what amperage your alternator puts out, okay? So we'll look at that. This is something really important. Everybody goes to the store, I need a new alternator. Well, what amperage is it? A 120, a 150, a 175, or 200? I don't know. So you take the old one off and you look, oh, it's a 120. So this, for argument's sake, just for this purpose, let's say you have a 120 amp alternator. Okay? What size is the wire coming off the back of the alternator? The red wire that's got a cover on it because, God forbid, should that connect with the motor, you're going to have a major fire. Okay, you never want, while it's running, to ever have the positive wire ground to the motor because you haven't got enough fire extinguishers for that. It's gonna blow the whole damn thing to pieces. It's gonna overheat instantaneously, and that alternator's gonna be done. 120 amp alternator requires, get this, you're gonna love this, a 1/0 gauge wire. What does your alternator have? Most of them are 10. Some of them are 8. That ain't big enough. The smaller the number as they go down, the bigger the wire, for those of you that don't know wiring. Your house is full of 14 gauge wire, okay? That's at 120 volts. That 14 gauge wire can handle 15 amps. That's what it's for. If you have a 12 gauge wire, you can handle 20 amps in the system, which means you really don't put anything more than 17 amps on the system, okay? You don't put 20 amps on a 20 amp wire. You put 17 on it, okay? Because 20 amps will blow the breaker all the time. You're right there. But that's just another, that's just a point of engineering. You need at 120 amps a 1 gauge wire. Good God, what if you have a 150 amp? This is how it works. Now you need a 2-aught wire. Okay? Double the size. You need a big boy. Okay? If you see my motorhomes or boats or anything I do, you're going to see every one of them. The start battery has got a 2-aught wire coming off of it to the starter. And then the alternator, depending on the output, will either have a 2-aught or a 1-aught gauge. And then we'll go a different direction because I'm not in there yet. I'm talking about starting and charging. Because when you take load, when you have equipment running, you're using power, you need to replenish. It comes from the battery, it's replenished by the alternator, and boom. All right, that's what's happening. But here's the problem, okay? It's a truck. This system is awesome for a truck. We do semi-trucks. They can have 3 and 4 huge 12-volt batteries in them, okay? So basically what they're doing is they're just piggybacking other batteries, okay? All on the same circuit, okay? They just have more cranking amps that way. They can turn the motor over better. They got more power to the starter because of that. They're not changing the voltage. It's all 12-volt battery. So what happens, you got more amps to start the starter. It takes more amps from the alternator to charge this mess up. You got more amps available for accessories. But remember, we're talking about the turn signals, the headlights, the wipers, the heater. We're talking about the radio, the power seats, the power door locks. All that stuff is attached to this system. Now, Ajax Motorhome Company buys a truck. All right, here it is. It's got an alternator, it's got a starter, it's got all its loads and everything. And what do? Wow. This is fun. This is what they do. They take and they add a couple of batteries. Let's do the coloring like I have it up here. Let's go back with my colors, right? Okay, they put another couple of batteries in here. And now the whole thing it's got a whole different set of terminology to it, okay? This is your start system over here. This is literally your start battery. Now these are your house batteries. Now what do the house batteries run? Now this is interesting stuff, because your house battery, where did I drop my lid? Because my pen will dry out. They're brand new. I'll find it somewhere here somewhere. But okay. So what's going to happen here is you've got these two batteries hooked together at the positive, hooked together at the negative, and then you're going down to whatever loads you have. What loads do you have on a motorhome? There's a good question. The loads that you have on a motorhome are things like the refrigerator, okay? It's kind of the primary one. You gotta have the refrigerator running cold all the time. The next thing would be the heater to keep it comfortable for you. Lights, so you can see what you're doing at night on your motorhome. You go in the bathroom. If you got an electric flush toilet, that's part of it. Generally, your water heater is 120, but there's some that are set up for 12 volts. So it just, everything is different. Depends on the supplies on this thing. It's going to drive me nuts with this thing. I hate drying these things out. But meanwhile, back at the ranch, where you see it down there? No, it ain't there. Nope. And it would have to be a black one. Oh, there it is, right there. Got it. Okay, now I won't go crazy. That kind of fanaticism is what gets you your electric working right. But everything is working off of this system, okay? So now, you got these great big fat batteries in there. And we call those deep cycle batteries. And they're really good. They have a lot of energy in them. They can run. But, how are these systems hooked together? This is the fun part. This alternator is charging these batteries. Now, if you think about it, one alternator and 3 batteries or 2 batteries or 4 batteries, whatever batteries you have, 2 here, 2 there. I'm going to get rid of these other ones because we're not dealing with a semi-truck. Let's just assume your motorhome came with 1 battery. So you got 3 batteries you're dealing with, okay? And these batteries use electricity at a different rate and have different loads. This one won't have as high amperage loads on. They're very low amperage. Your heater isn't that high. Your refrigerator isn't that high. It's a few here, it's a few there, okay? Lights aren't that much, but it's a few. This has huge amperage because a starter, when you grind it, does a lot of amperage. You're talking 200, 250 amps to start the motor. But it's huge amperage. But as a percentage of what you're yanking out of that battery, it's very small. When you're dealing with these small loads on your house batteries, they're small amps, but there's a lot of them. And it's for a long time. The starter, if you got a good running motor, okay, that starter is going to run for 5 seconds. How much battery did it take? 3 minutes worth of charging? Okay, that's fine. Let's call it that. Let's just call it 5 minutes of charging, all right? So what we have is an alternator that's running wild. It senses the lower batteries, which is this one here. So it's charging as high as it can get, which is overloading this battery, okay? It needs 5 minutes of charge. It's getting a constant charge on it. So it's cooking the start battery, literally burning it to a crisp, okay? The alternator senses it's full eventually and shuts these off. Shuts off completely and doesn't charge those. So your house battery is almost like you got a glass of water sitting here, all right? And it starts up here and, you know, all night you're using it and you get down to about here. You fire up the motor and it only can get it charged to about here, because it shuts off. It senses so much voltage between the voltage here, what's left there, and what's in here. It shuts off. So here you are here now. So the next day, you fire it up, and you're down here, and everything shuts off. Fire it up, charges that thing, senses it, brings it back up to about here, but you're always running down. Now, well, one thing that happens to a deep cycle battery, you cannot keep running them dry. You can run them low, you can't run them dry. If you run them out, to where you get up in the morning and the refrigerator isn't working, the lights won't even come on, all of a sudden, you're murdering that battery. You're murdering this one, but here's what's happening. Because they're hooked together, now you suck that one dry, you're sucking this one dry. So if you're using a lot of power, which people do because they got their computers running, sound systems, everything's running, you're going to take the start battery out. It's going to run out of power. Okay? You run this one out, that one's going to run out. Maybe they run out together because the systems are tied together. The bottom line is you got nothing to start your motor with. So our system, which is really a modern system that works extremely well, we go about it completely different. And one of the things we do is we consider one battery in this unit, whether it's a boat or it's a motorhome, we consider that battery to be sacred, okay? One battery is sacred. It never gets beat on, okay? This battery does one thing, okay? And I'm going to show you what it is. Drives people nuts, because once you come up with it, they're like, oh, how did we do that? Why didn't we do that earlier, you know? But this is what's done. This is, and I didn't invent this stuff, believe me. It was invented long before I came along. Your start battery. This is the battery that came with the truck when they put the motorhome together. We call that the start battery. And you know what? That's all it does. One thing in its whole life is starting the thing. The beauty of it is, if you use it for nothing, and I'm talking about not even running the motor off this thing. I'm talking about the engine runs separate from this. This battery does one thing. It runs the starter. It does not run the wipers, the headlights, the horn, the gauges, nothing. This battery runs the starter. Now, you have another system here. Remember this one? The one that's always dead? Mostly it's two batteries, two deep cycle batteries, okay? And what these do, oddly enough, is they run all the accessories. They run the refrigerator, the heater, the lights. They even run the motor when you start it. Everything. I'm going to put this down here. Okay? Here's that box with the XYZ. So the XYZ that was on the truck is now XYZ that's here. Okay? This is everything but starting the rig. Okay? So here you are hooked up this way. But now you say, Bentley, okay, that's all well and good. How the hell do you charge this mess? How does this work? Because here we are. That just starts the truck. What's going to run it? If the batteries are dead here, the truck ain't going to run. You're right to a point. You're absolutely right. You are absolutely dead on correct. Here's what happens. This is what we do. You don't see the alternator there, do you? The alternator isn't there at all, but it's still there. The alternator over here, of course, it's grounded to the same place this is grounded. These all have common grounds, okay? There's no separate grounds. All ground is ground. You got your alternator over here, and what it does is goes to an interesting little thing called a bus. Now, a bus is a place where you put a whole bunch of wires, okay? You hook all these wires in there, and there's smaller wires, and there's one big wire over here that goes to your battery. So you have this bus here. Let's just, I can show you a picture of one, but not for right now. Let's just have a bus here. Big wire there, little wires going across here, okay? And this big son of a bitch is hooked into the house battery, okay? Now, what's hooked into the bus? I call it a charge bus, and there's a really good reason for it. Your solar, okay, shore power. You have a converter when you plug it into shore power that's charging your batteries, okay? You don't want it to charge that one. You want it to charge this one, okay? Your solar, the alternator, okay? Let's talk about that, the alternator, okay? And in a simple system, you can take your loads off of there too, okay? Those all go through what's called a charge bus, and that keeps these healthy. So you're not running your house batteries down, okay? You're not killing them. You're letting them come down so far and they charge back up. All right, here's the thing. How the hell do we charge this? You know as well as I do, if you hook those two together, that son of a gun is going to drain the battery too. Well, there's a lovely little device that a company named Blue Sea makes, because everybody's heard of an isolator, okay? An isolator is old-fashioned. It is the biggest piece of crap you can have anywhere near your boat or motorhome. An isolator is simply a bunch of diodes, and the first thing that happens is 25% of your power is sucked up by those diodes. And the way you tell is that isolator has a heat sink on it. It's got fins on it. The reason it's got fins is to get rid of the heat. The heat comes from the diodes. So what we've done at this point is we take the isolators out. We don't allow them. Because, number one, they don't charge the batteries based on what the need is. They just charge them, but they're stealing from the alternator, okay? Well, your alternator up here, okay, 120, let's call it 120 amp. So now you've got a 1-aught wire going down here, bada boom, bada bing, okay? The alternator's charging the house battery. But there's something else that's happening down here. You have another wire. You can run an 8 gauge up here, okay? You run that up to the start battery, run that down, but there's a big hole in the middle, right? Big hole in the middle. But the fun part is, this device that's made by Blue Sea, it's called an automatic charge regulator. And this bugger is your lifesaver. This sumbitch is fantastic. An ACR, okay? An ACR, automatic charge regulator. It's got some other wires on it. It's got one for a light, it's got a ground, and it's got a sensor on it, okay? So what you're doing with it, the ACR, clever device it is, because this battery only loses not even 5% of its charge starting the starter, it doesn't need much charging. So we said before as an argument point that it requires 5 minutes to recharge it for starting the vehicle, okay? So what happens is you start the vehicle, the alternator begins charging, it's charging the house batteries that your motor's running off the house batteries. Your motor's not running off this, your motor is running off of this, okay? All loads go through the house battery. The only load that goes to the start battery is the starter, okay? Alternator starts charging it. Whoop-de-doo, it's charging up the house batteries. It doesn't know what to do. The alternator just says, oh, I need to put power in here. It's like I got a pitcher of water, I'm pouring it in, okay? It doesn't know anything. You don't want a regulator in the alternator, but that's another story. We won't go to that right now. Let's just assume the regulator does its job the way it's supposed to. It's not even sensing what this battery needs because it needs to know what this needs. All right? It needs to meet the needs of the house batteries, and that's its primary job. But here's this wire going up here with an ACR. Now, what does the ACR do? The ACR says, oh, my start battery has 11.9 volts. It closes the circuit, allowing the charge to go to the start battery. And then when it reaches up to the top to the float, which let's call it 13.2, 13.5, closes it off, no more charging up there because that battery doesn't need anymore. If it goes any higher than that, it's going to burn it up, okay? And, you know, there's some argument for 14.2 volts versus 13.5 or whatever, but basically, you know, anything much over 12.5 is in your favor, okay? But anything much over 14.2 is destroying the battery. So we're assuming the regulator that's on here is doing its job the way it should. It's charging the bus. It's going to ACR on and off. That way, The whole thing is you want your starter to be sacred, because if you run these two down, you got to be able to start that. And how are you going to start it if you don't have a start battery? Now, what happens if these are totally dead? The motor won't start? No, it'll start, because the sense will go the other direction. It'll close this, and the start battery will start, give enough power to start the motor. It works backwards too, only momentarily. It's not designed to be a two-way street. It's designed to be a one-way street. But when you're sacred, sometimes you got to be borrowed. Okay, so here's where we go. Now, talking about alternators and regulators real quick. I'm going to take a minute on that, and then I'm going to show you a couple things, and I'm going to shut off because I'm long-winded when, you know. But that's, and if my videographer laughs, I'm going to kick him in the nuts if I could reach that high. No, that's my son. He's fine. He jokes with me all the time, but it's cool. All right. So when you have an alternator, we've gotten used to regulators that are built in. Now, the regulator gets hot, it gets cold, it gets hot, it gets cold. It's sensing the voltage right there, but it's not as efficient as it should be, because it'll shut off when it gets too hot, and usually it gets too hot, okay? So what we do is we have a little thing that I love, and it's an external regulator. We are strong believers in Balmar alternators, okay? Balmar alternators are humongously powerful, they're expensive, and they're highly reliable. But when you don't have a regulator in your alternator, you'll have a little regulator over here, okay? Separate. And the beauty of it is, here's this regulator, and it has a whole bunch of connections you can plug into that connect to the alternator and make it come on and off. There's a 4-wire thing that does 90% of the work, but you can adjust this other stuff. There's also sensors. Here's something that's really interesting. This sensor, you have a sensor going over to the battery here, and that sensor tests the temperature of the battery, and if it's getting too hot, it shuts the alternator off, lets it cool. It has another wire. I'm going to drive right through this stuff, okay, and it goes over to the alternator. And what happens if the alternator gets hot? It shuts it off. That way you're not cooking your alternator. So you've got two things in your favor. You've got a wire that's big enough to handle the power of your alternator, and you got a sensor and a regulator that says, take a break. All right? This bastard's a marathon runner, man. And the marathon runner's got to stop and rest for a minute. The battery has to stop and rest for a minute. If you don't do that, all this shit's going to die on you. The alternator will die prematurely. Look at every alternator in the world. You drive down the road and you got a really nice stereo, and what do you hear driving down the road? From the alternator. Why? Because it's fighting its ass off to push all the power through the wire that you're asking for, and your wire isn't big enough to take all the power you need. You put a big wire on your alternator that's the proper wire size, okay, for that damn power that's putting out there, and that wire goes to the battery, all right? Not to the starter, not over here, not over there. The wire from the alternator itself goes right smack dab to the positive terminal in the battery. You're going to have a lot less noise, and you're going to have a lot less heat. And this son of a, and it's going to last a lot longer. You have an alternator that's dying every year or two, tired of that shit, well then, fix it. Don't keep replacing the damn thing. Don't keep blaming the alternators you're getting, although about 50% of them aren't worth a shit nowadays. The fact of the matter is, if your alternator is getting treated properly, it's going to treat you properly. But until you do, you're going to have problems. So here's this regulator, this external regulator, and there's regulating temperature. It's regulating the temperature at the battery and at the alternator. Oh, yeah, that's right. It's regulating temperature on the start battery. It's going to know all these things. It has to. It's very intelligent. And what it does is it saves your system. Now, on the boat, we have two Balmar alternators. We have two motors, right? And I got to redo it. I've got one of these Balmar regulators, but because I have two Balmar alternators, I need to have two of these, okay? This isn't the motorhome. I'm just talking about a system so you get an idea how it works. So I have to have a second one for the second alternator, right? And then you can't use that by itself because the alternators are providing power and the regulators are doing their job, and there's two of them. They start bouncing off each other, okay? Not a good thing. You don't want them bouncing. So what they have is another regulator that goes in here. Clever enough, they call it a center fielder. What does a center fielder do? It does all kinds of things. One, it keeps the alternators from bouncing around with each other, but it takes advantage of the fact you got two alternators instead of one. When one starts getting hot, it shuts it down and lets the other one work. That's the big advantage because you're not cooking your alternators at full bore. But when you've got those Delcotrons running in there on your boat, both engines going like hell, they're fine like hell. People say, oh, well, I'll just put one on the start battery, one on the house battery. No, doesn't work. Because when you find out one alternator dies, you're done. You cooked your batteries, you did this, it's just not right. This is the proper way to do it. External regulators, 2 alternators, 2 regulators, and a center fielder. Just got to get ahead of myself, but you'll never do that on a motorhome unless you put 2 alternators on it. And some people do, by the way. So that's what you're born with. That's your system right here, this truck system. And it works great in a truck. As soon as you put a house battery on it, you just screwed the whole equation up. You just totally screwed the pooch. All right, so now I'm kind of done with that part. Right now we'll go into more stuff as we go later because I'm going to show you the wiring we use. We're going to show you the connectors we use and why this system is so much better than what you're running on your motorhome now. But I wanted to kind of go over here. I have this fun little workbench I'm putting together. I got this huge shop. I mean, it's fantastic. I set this workbench up, and the reason is, I set this up for a very good reason. It's a back wall. I can drill a hole through here and put an exhaust pipe here, because what do I have sitting here? This is a diesel furnace. This is a little Chinese diesel furnace that I bought on Amazon, and everybody's getting them. They're little garages, they're hooking them up and keeping their garages warm. People in Canada are just having a great time with them. You know, their shop is useless all winter because it's 40 below outside. This son of a gun makes it nice and warm. But here's the fun part. There are efficiencies that you can create with this. There are situations you can change. Now, my house, I am going to get it as off-grid as I can possibly get it. So when the wind blows, which it does constantly, and we lose power, we can still be warm, still have water, and still have electricity. Just got that all figured out. It's going to a 12-volt lighting system throughout the house. Going to have some deep cycle batteries. We're going to have some solar panels outside to charge those batteries and to run this. The fun part is this makes a lot of heat, but it throws a lot of heat away. The exhaust comes out of here, and I've been watching 200-degree centigrade exhaust coming out of here, okay? That's a lot of wasted heat. So other things I've been researching are ways of preserving that energy, keeping the heat. And what I'm using is basically a 5-gallon metal jug. It's got stuff in it. I'm going to get it out of there, clean the thing up completely. And what I'm going to do is I'm going to bore a hole in here, okay? And there's a reason why you bore the hole in and it comes in at the top and goes out the bottom, because as it cools, it condenses moisture, and you don't want moisture stuck in the pipe. So it'll go out this way, but it won't go the other way. So I'm going to bore a hole here, wind the exhaust pipe around inside this thing and make it come out the other side, then run it out the door, run it outside the building. I'm going to fill it with sand. It's effectively called a sand battery. And sand has the ability to hold a huge amount of heat. So I can take 200 degrees centigrade, which is over 300 degrees Fahrenheit. The sand's going to absorb that. Every time this thing is on, it's generating heat going through there, and the heat is being absorbed by the sand. I've been watching some of the YouTube videos that when it comes out the other side, it's like at 15 degrees centigrade, which is minimal. I think, what is it, 55 degrees, 53 degrees, something like that. So you can put your hand on the pipe. The pipe going in will give you burns. The one going out, just warm your hands. But the nice thing is you've sucked up all of the energy from your diesel fuel that you're putting through here. And then this sand battery, we put one of these on top. If you guys haven't seen one of these, they're your best friend. It's an induction fan. It requires no power whatsoever. You put it on a hot surface, and that thing will spin like crazy. I don't have a hot surface right now, or it would be just spinning like crazy. The beauty of it is you can charge one of these up, disconnect your hoses, and take it somewhere. You can put it in a cold bathroom or a cold room, and this fan will do everything you need it to do for hours. I don't know what the time factor is. I've got a CO meter coming so I can find out how much carbon monoxide I'm producing, because that's the dangerous part of this equation. And, you know, just knowing what kind of heat I'm dealing with and how long. It'd be just interesting to see, does a sand battery last 2 hours, 4 hours, 6 hours, 8? I hear people tell me they last 48 hours. I don't know. I mean, some of them are going to 600, 700 degrees. That's a whole different world. We're not going to get that high. But then we do have these little gadgets. You hook these up. These are for 120 volts AC. You hook these boys up, and they'll generate a great amount of heat. So they're also going to be in the sand. Let's see what they do. I don't know. You know, you hear stuff, you see stuff, people are saying things. I want to do this for real, because this system I'm going to generate right here. I'm going to build it, do whatever I have to do, refine it. And that's my first heater that goes in the house, and we'll go from there. So part 2 coming up. Hey, like, subscribe. Send us some damn money, will you? Oh, God. Contributions welcome. If you want us to check something, send a comment and say, look, hey, try this, see if this works. What do you think? We'll go from there. Take care now.